here is the simple CO2 cylinder head arrangement, valve arrangement. It's a pilot operated type. So first let's understand the various components. This is the siphon tube with which we can, let's say the CO2 bottle is long enough. So the siphon tube goes to the bottom of the CO2 bottle. Let's say this is the CO2 bottle. The siphon tube goes right to the bottom and comes up to the cylinder head valve, and this is it. So the CO2 when released will come through this pipe, and it will come through this pipe. When this valve is opened, then it will go through this. It will go through the space, and then it will come out through the opening. It goes to the main manifold and then to the engine room or the protected space. As you can see here, alright, I'll just erase this. One important thing what you have to note down here is that, like here, as you see here, there's a small curve, very fine curve given here. This is the CO2 as it comes here, along with the spring force. Just have a look. Along with the spring force, it keeps the valve shut. This is the main check valve. This main check valve is kept shut by the CO2 bottle pressure and the spring force. Thus the CO2 cannot escape out until the pilot CO2 comes and activates here. With this in mind, let's now understand how the system works. Alright, so this part is clear now, and here you have the stem or a spindle like arrangement with a piston, a spring loaded piston, and then this is the head cap or groove nut which is just sealed. You can, during maintenance, you can remove this and remove the piston and then get access, but this is done only in shore. And here you can note there's a pilot check valve and the safety valve. I'll enlarge it. Alright, so this is the pilot check valve, and here is a safety relief, maybe a bursting disc or some relief, spring-loaded relief valve depending on the design. So as you see here, here's the pilot inlet. It will be usually threaded in this space so that we can connect a ferrule of the CO2 pilot bottle. And as you know, the CO2 pilot bottle is roughly 1 to 2 kg. It's a small bottle. And now, alright, so now, as you know, the bottle pressure, the CO2 comes here, along with the spring force keeps this valve closed. Now you're operating CO2 pilot bottle, the CO2 comes here. Now this pilot check valve cannot be opened by the lower pressure CO2 from the pilot bottle. The 1 or 2 kg CO2 from the small pilot bottle cannot open this pilot check valve. The reason is the CO2 inside the main bottle is more pressure, so the back pressure is more. It cannot open now. So it will travel through this path. I'll change the color. Just trace out this blue line. It will travel through this path. It climbs up, goes, and then goes here and actuates this piston. The piston moves down. You must wonder, or you will wonder, how does the lesser pressure CO2 can open this valve against higher pressure CO2 inside the bottle? It's very simple. The idea is having a large area piston. I'll explain once again. I'll enlarge the picture. Now, when you see the area of this piston, let's say this is X, this piston area is more when compared with this. So as the area is more, with the hydraulic basics, lesser pressure or smaller pressure is sufficient to push it down since the area is more. And as it is pushed down, the stem moves down and then opens this valve. I'll minimize it. Alright, let's be clear now. Alright, so as the pilot CO2 through this channel opens the piston down, the piston moves down, the stem also along with the piston moves down, tapping the main check valve here, and as it is tapped it moves down against the spring force. And then the CO2 comes here. Similar to the boiler safety valve, we have a lip-like arrangement, the curve. The CO2 from the main bottle, I'll change the color and explain. The CO2 from the main bottle comes here, it travels like this and then gives a push, here, thus enabling the valve to open more. As the valve is opened, the CO2 goes through this, and here is the stop check valve, which means it's a non-return valve. It will push the non-return valve up and goes to the discharge manifold. Now, as you ask the pilot check valve when it will open its purpose, the CO2 which is trapped inside above the piston has to release somewhere. Where it will release, and that will be after this bottle CO2. Let me explain you. This CO2 which is inside the main bottle completely escapes, and the regulation states that within 2 minutes 80% or 85% of the CO2 should be allowed into the engine room. So roughly, let's say after 5 minutes the CO2 goes to the engine room, the bottle remains empty, which means there is no pressure at this space. Thus the pilot CO2 space has higher pressure, and then it pushes the pilot valve opens, and then the trapped pilot CO2 escapes along with the main discharge manifold. That's how the CO2 cylinder head valve works.